ओके, थैंक यू। नेमा सर नमस्ते।
पांडे जी नमस्ते, कैसे हैं?
बढ़िया है सर, नमस्ते।
अच्छा, मैं तो अभी देखा आपने फूड वाले ग्रुप में, तो मैंने कहा अरे पांडे जी इतना बढ़िया प्रोग्राम कर रहे हैं, चलो ज्वाइन करते हैं।
ओके सर, थैंक यू। एक्चुअली द प्रोग्राम इज फ्रॉम दिस IIT खड़गपुर।
अच्छा,
ये हाँ सर।
ओके ओके।
हाँ
तो
हाँ,
मिश्रा सर का लेक्चर है इसमें?
मिश्रा सर आएंगे। लेक्चर लेक्चर तो सर मैं ही दूंगा। ही विल
अच्छा,
बी देयर सर। हाँ,
ओके ओके, चलिए कोई नहीं, आपको सुनेंगे आज।
ठीक है सर, थैंक यू।
ठीक है।
अजय पांडे जी।
हाँ नमस्ते सर।
नमस्ते, गुड इवनिंग, कैसे हो?
बस सर बढ़िया सर।
वेरी गुड वेरी गुड, चलो अच्छा है आज।
नेमा सर भी जुड़े हैं सर।
हाँ जी।
पीके नेमा जी
सर
भी।
नमस्कार सर।
हाँ देख रहा हूँ, निमा का नाम देख रहा हूँ। गुड, वेलकम
ने-
वेलकम भाई, निमा जी वेलकम। शिव
थैंक यू
शंकर
सर,
इज
थैंक
आल्सो
यू।
देयर।
अब
हाँ जी बताओ निमा।
सर अभी अभी देखा मैंने मैसेज तो ग्रुप में, तो मैंने कहा चलो मैं भी ज्वाइन करता हूँ। सर से
बहुत
भी मुलाकात हो जाएगी, पांडे जी से भी हो जाएगी।
बहुत अच्छा किया, बहुत अच्छा किया।
जी
गुड, वेलकम। और शिव शंकरी, हाउ आर यू? यस, आई थिंक योर माइक इज नॉट वर्किंग. People are joining.
Hello, sir.
Yes,
Sir,
Shankari.
good evening, Shankar. I'm good, sir.
Yes.
Thank you. How are you?
Oh, everything fine. I am also fine. So you are in Bhubaneswar?
Sir, Katak.
Cuttack, sorry. CRI Cuttack, yes.
Yes,
So
sir.
how are the things going on at your institute?
Yes, sir. Going good.
Hope they have contacted you as well.
Sir, sorry.
Someone contacted you
From where, sir?
from our this team
Yeah.
FCTL.
Yes. One of your students, she called me. Yeah.
Yes, good. Okay. पांडे जी, बहुत क्या बात है, बहुत एकदम से फ्रेश लग रहे हो, अच्छी बात है।
हैं
लुकिंग
सर।
लुकिंग स्मार्ट,
ये
ग्रेट।
सर शेव वगैरह किया है तो मैं भी और तो कोई ऐसा स्पेसिफिक कुछ।
गुड गुड। तो नेवा जी, और कैसा चल रहा है आपके यहाँ? निफ्टम सब अच्छा है सब? निमा, तो पांडे जी अभी आप ऑफिस में हो आप लोग?
यस, हाँ सर, हमारा तो ऑफिस खुला ही है।
ऑफिस तो खैर हम लोग क्या, IIT में भी ऑफिस खुल गया है। ओनली स्टूडेंट्स आर नॉट देयर, बट अदर एक्टिविटी तो हो गया सब।
हमारा तो सर लॉकडाउन केवल 1 महीने का रहा बस, बाकी तो तब से ओपन ही है।
स्टूडेंट्स हैं?
नहीं,
स्टूडेंट्स
15 अप्रैल ऑनवर्ड्स ऑन है, हमारा चालू है। हम लोगों को आना है ऑफिस।
नहीं, आप लोग को आ रहा है? हम लोग
स्टूडेंट्स अभी तक नहीं है।
स्टूडेंट्स अभी तक नहीं है ना?
नहीं, लेकिन शायद मे भी अगले हफ्ते तक, शायद 1 मार्च या ऑनवर्ड्स स्टार्ट हो जाएगा।
अच्छा, तुम्हारे यहाँ क्या पोजीशन है नेमा जी? डॉक्टर नेमा,
हाँ सर।
आपके यहाँ क्या पोजीशन है अभी? स्टूडेंट्स हैं कैंपस में कि नहीं?
हाँ, नहीं अभी सर स्टूडेंट्स को ना कॉल करना शुरू कर दिए हैं।
अच्छा,
तो स्टूडेंट्स हैव स्टार्टेड कमिंग, और उनको बैच वाइज बुला रहे हैं। जैसे 4th ईयर वालों को पहले, और एमटेक 2nd ईयर को पहले, और फिर 3rd ईयर, 2nd ईयर, और सबसे लास्ट में 1st ईयर को बुलाएंगे।
राइट राइट।
हाँ, लेकिन सर अभी अचानक फिर से केसेस बढ़ने लगे हैं। तो
हाँ, अभी कुछ मतलब मुंबई इत्यादि में, बंगलोर में, मुंबई में थोड़ा कुछ बढ़ने का केस आया है।
हाँ हाँ, मुंबई में हो गया। और सर थोड़ा यहाँ थोड़ा सा इसलिए भी डिले हो सकता है, यहाँ क्या फार्मर्स का प्रोटेस्ट चल रहा है।
अभी वो खत्म नहीं हुआ तुम्हारे यहाँ? सिंगू बॉर्डर क्लियर नहीं हुआ?
नहीं
अभी
नहीं, पूरी बॉर्डर क्लोज है सर अभी भी। और
अभी जो चंडीगढ़
आना जाना बड़ा मुश्किल होता है।
अगर चंडीगढ़ इत्यादि जा रहा है रोड बाई रोड से, उधर कैसे जाते हैं लोग?
जाने के लिए सर मतलब वो रास्ता है, पर वो फिर ना गांव के अंदर से होके है।
हाँ।
और उसमें काफी 1 घंटे की जगह 2-3 घंटे लग जाते हैं,
ओ,
क्योंकि गांव की रोड बिल्कुल पतली है, एक सिंगल रोड है। और जीटी रोड का लोड उस पे है, तो काफी मतलब तकलीफ है सबको। और अभी तो पता भी नहीं है कि ये कब तक चलेगा।
सरदार जी लोग मानेंगे नहीं?
कोई निश्चित नहीं सर कब तक चलेगा। अब आपके यहाँ चुनाव नाव हो तो शायद उसके बाद कुछ ठीक हो माहौल। अब तो सारे नेता लोग बंगाल की विजिट में ही व्यस्त हैं। चलिए सब बढ़िया है। अभी तो मैं अचानक ही वो देख रहा था तो मुझे ये दिखा, तो मैंने कहा अरे वाह, पांडे जी का है लेक्चर, सर भी है, तो चलो ज्वाइन कर लेते हैं।
आए तो हमारे यहाँ तो पिछले करीब पिछले अक्टूबर से आई थिंक दे हैव स्टार्टेड एंड एवरी अल्टरनेट सैटरडे।
अच्छा।
एक सेमिनार कर रहे हैं अपना जो पुराना
बहुत अच्छा
अपने एलुमनाई लोग उसमें बोलते हैं।
इट इज ए वेरी गुड गैदरिंग सर, और एलुमनाई का भी ऐसे होना चाहिए, बहुत अच्छा है ये तो।
हमारे लैब से जितने पास आउट हैं वी आर रिक्वेस्टिंग दे आर कमिंग एंड अपना एक्सपीरियंसेस अपनी एक्सपर्टाइज शेयर करते हैं। इट इज बेसिकली ए नॉलेज शेयरिंग
इट इज ए गुड इनिशिएटिव सर, एंड गुड इनिशिएटिव। और हम लोग आपस में ही अपने नॉलेज को शेयर करेंगे तो इट विल बी सो गुड, एवरीबॉडी विल बी बेनिफिटेड।
That's what we are getting. It at least now many people are joining and it is becoming popular. At least जो भी है हर लेक्चर में देख रहे हैं 100-200 को थ्रू फेसबुक लिंक, गूगल यूट्यूब लिंक, फेसबुक और यूट्यूब में लाइव रहता है, बाद में भी लोग देखते हैं, तो एटलीस्ट पीपल आर गेटिंग इंफॉर्मेशन स्प्रेड हो रहा है, अच्छी बात।
बल्कि इसको रिकॉर्ड करके यूट्यूब में भी रखना चाहिए।
नहीं रह रहा है तो यूट्यूब में है, और हमारे फेसबुक में, हमारे लैब के फेसबुक पेज पे तो लाइव रिकॉर्ड हो रहा है। इट इज दे आर ऑलरेडी
अच्छा।
इट इज ऑन द FCTL फेसबुक पेज एज वेल एज यूट्यूब लाइव है। तो जिसका सिद्धांत यूट्यूब में है तो
ओके, बहुत बढ़िया है, इट इज गुड।
तो बाद में भी कोई चाहे देख सकता है।
हाँ
गुड।
वैसे भी अभी कोविड में कहीं आना जाना तो हो नहीं रहा है, तो एटलीस्ट ऑनलाइन ही लोग ये कर लें।
आई थिंक हृदय लगता है पांडे बहुत पॉपुलर, मिनी आज देख रहा हूँ बहुत से न्यू फेसेस आज ज्यादा दिख रहे हैं। गुड। पांडे के चेले हैं सब।
नहीं सर, HBTU के स्टूडेंट्स हैं, hbtu.ac.in करके।
गुड।
HBTU के स्टूडेंट्स हैं हम।
अच्छी बात है, गुड।
नहीं, अभी मैंने अपने स्टूडेंट्स को भी फॉरवर्ड किया है, सम ऑफ देम में ज्वाइन।
जहाँ 5-6 हो रहा है, पांडे से पूछो जी रेडी, तो अपना स्टार्ट भी कर सकते हो, थोड़ा फॉर्मेलिटी जो है अपना करो, तब तक ज्वाइन कर लेंगे लोग।
सर आई एम रेडी, आई हैव ऑलरेडी टेस्टेड।
हाँ ठीक है सिद्धार्थ। And I think Hridyesh Pandey, he has been one of the very sincere student of his time. And when he was here, I don't know that while he was going out of the laboratory all the time, whenever, even throughout the day and night. And I think when he came, we had got one new equipment at that time, that FTNIR, all right? FTNIR system. So Pandey he was always working on that system and complete data calibration and everything. And one very special thing about Pandey, that he always help to everybody. That is a very good and positive attitude which he had, and I think which is ultimately paying him. The association, in fact, he has always been in each and every FCTL activity. I find him there actively involved, so he is very actively associated, and now I'm very happy that after from here he went to Pantnagar for some time. From Pantnagar finally he moved to Anand, and now at Anand he is stabilized and he is doing very good job. Recently I had an opportunity to meet him personally, of course before COVID. That is अभी COVID को छोड़ दो तो recently ही है. तो हम लोग मिले थे, and I am happy that in the way his performance is there and it's very nice. So let us hear Dr. Pandey. Right, welcome Pandey ji.
Thank you, sir. Thank you very much for expressing your views with regard to me. I thank you for inviting me in this.
I think Siddharth had to do something. Siddharth also something. They have little more customary, Pandey ji.
Okay, sir. No issue.
ठीक है सिद्धार्थ, continue.
Thank you, Siddharth, for a nice this introduction about myself. I I will be sharing my presentation. Please let me know once it is being visible to you, and if in case there are some issues, you can tell me in between. Yeah, so it is visible. No, 1 minute. I have to share. It is visible. Actually, we nowadays, since last 1 or 2 weeks, we are facing some network issues and network problem. So if there are some issues, so please let me know. in between. So I will be sharing the. It's not yeah. So I will be discussing about food extrusion, mostly experience with regard to our institution at AAU Anand, and a little bit some of the trials which we have done, and some new information or this what people are working on. So my presentation will consisting of introduction with regard to extrusion, then development and classification.
जरा presentation mode में चले जाओ.
Again, sir.
PPT presentation mode में पूरा.
It is full screen probably. एक minute.
No.
It is not.
No.
I have made it presentation mode. I have to check one.
I have 5 at the now I think it may come now.
1 minute, sir. Again, मैं एक बार दोबारा से. I am sharing. I don't know. It is visible, sir.
The slide is visible.
हाँ.
It is visible, but वो ये presentation mode में नहीं दिख रहा है.
हाँ.
ऊपर स्लाइड से क्लिक करो, देखो हो सकता है वहां से हो ऊपर से जो स्लाइड्स.
F5 कर दो. F5.
F5. Okay. I have pressed it F5 because I am not able to see anything other than that my slides.
हाँ.
नहीं हुआ नहीं है आप फिर.
Refresh option. It is not being shown in the refresh. I have to in show. 1 minute. In show. I am again sharing it. Okay, probably it is in the window, so probably ऐसा. 1 minute. I have to share. Is it visible?
Yes, fine, good.
Okay. So my content presentation will be introduction, then development and classification of the extruders, then what are the various functions one can do, and what are the various parameters within the extruder, then various extruded products, how they what different sort of products one can obtain through the process of extrusion, its application aspect, where we what different products we can prepare through the extrusion, and then a little bit of with regard to the work which we have carried out at AAU Anand on extrusion, and finally the trends and challenges in case of extrusion. So with regard to food processing, there are various factors which are the drivers for the demand of the product, and some of these are being listed over here. We are going for the product with the increase in the this spending money available with us. Then nowadays most of the families, they are more nuclear one, and number of times within those nuclear families where we may find that the women, they are working, so that is another thing. Then people, they are more conscious, so they are looking for those sort of food products which provide some health benefit beyond basic nutrition. Then other than that, this urbanization and lifestyle aspirations, they are other factors which are there, which are leading for this demand for the growth of this food products. Then why we are looking for this extrusion cooking? This extrusion cooking, it is quite versatile in nature. The processing cost is low, and we have higher productivity, and the product quality is improved in terms that there's more hygienic food products they are being obtained, as well as this most of the microorganisms which might be present. Number of times they may get deteriorated or destructed if we are using high temperature processing. Then it's environment friendly, no this waste as such it is being generated whenever we are carrying out this extrusion process. Specifically liquid waste generation is negligible, which is number of time one of the major problem, specifically in different sort of food processing industry, specifically dairy industry or maybe fruits and vegetable processing industry. Then we can have different sort of different shape products. We can control the parameters or the depending on the type of the dyes being used, we may get different shape products, different texture product, as well as we can incorporate color component to achieve or obtain different color product, and further it is quite easy to scale up. With regard to the development, initially this extrusion it was being used for developing, or this is specifically in the polymeric things it was being used, but with regard to the food processing, the people they use somewhere in it is being reported somewhere in 1797, this Joseph Brahma, he prepared some sort of pasta product, and you may find this common extruder being used at household level for production of simai or semolina or similar sort of product. Then later on, this fellow and Bates, they developed the twin screw extruder for manufacture of sauces, and then later on further this commercial application of this extruded were being done, specifically in case by General Mills in US. They use single screw extruder to produce ready to eat cereals. Then later on expanded corn kernels or collets, they came into they were being developed, and after World War II in 1946, their commercial they were commercially available in market. And then in mid 1970s, second generation the segmented screw and barrel cell, specifically by Wenger and other organization, it were being developed. So this was the brief history. I have taken this historical information from this extruders by Riaz. Then extruders, they are being classified on the basis of various classification. Maybe they are like on the basis of the shear being generated within the extruder. They may be low shear forming or cold forming, then low shear cooking, medium shear cooking, and high shear cooking. These are the classification on the basis of the shear force being generated within the extruder, and on the basis of heat generation, it might be adiabatic or isothermal, where we may control the this temperature within the system. Then it may be polytropic. So the temperature, it goes on increasing in one particular direction or maybe multiple direction. On the basis of the configuration, we may have single screw is the extruder where we are having single screw, and twin screw where we are having more than one screw, that is. And within the twin screw, we may have different configuration which might be classified as co-rotating intermeshing, co-rotating non-intermeshing, counter-rotating intermeshing, then counter-rotating non-intermeshing. These are the various classifications of the extruders, and there is this typically is a single screw extruder. From this you can have idea that what this extruder is. Here it's a drive or gear which will move the screw, and there is a feed hopper through which you can incorporate this ingredient into this extruder. Then within the extruder we are having, or the whole extruder barrel it can be divided into 3 different sections. One is being called as feed section, where the feed it comes into the barrel. Then a little bit of mixing of the product, it occurs within the feed section. Ingredient, they can be mixed. Then the compression section, as from the figure you can see the it is tapered in shape, and the screw is tapered in shape, and towards the die the distance or this gap between the barrel and the screw is less. At the initial stages the gap is more, and at the ending this towards the end the gap is very less. So due to this, as the product it is being forced from this feed section to the next section, due to the movement of the screw, this compression of the mass or the material occurs. And further in the metering section, this due to this high pressure being generated, as well as due to temperature being generated, this products, it number of times it gets into molten form, and there is a small discharge at the end from where this extruded product it comes out. So the moment it comes out from this die, it comes into inside, the temperature is high as well as it is in molten form, and instantly the moment it comes out, it is in it comes to the ambient temperature. So number of times, specifically for hot extrusion process, this product it gets expanded in the condition, and normally there is a blade being fitted at this die end, and which cuts the extruded product into the desired size. So depending on the type or the shape of the die, we may have different sort of product. So these are the various functions which may be or which are possible within the extruder, like mixing of the product ingredient, it can be carried out. Then you can have you can remove the gas, specifically if we are having some fibrous ingredient within the product, so the degassing of those fibrous ingredient might be possible due to the compression. Further, this homogenization, it is also possible due to continuous mixing and mixing of the product, as well as further breaking down of the product into the uniform particle size. Then grinding, it also occurs due to the shear being generated, different type of shear forces being generated. Then starch cooking, or this cooking of the starch component within the product, it also is there. Specifically, number of times this the cooking of a starch, it is being considered as a gelatinization, or this the gelatinization of the starch, it is possible. Further, the temperature, they may also carry out denaturation of the protein. The typical 3D structure of the protein, it may get broken down, and this protein, it may get denatured. And further, texture can be altered. Specifically, we may have texturized vegetable protein product, sort of product can be obtained through extrusion. Then enzyme, they too are being inactivated. Other than enzyme, different sort of anti-nutrients, they too are being inactivated, specifically in case of this hot extruder, or where the temperature they are above 100 degrees centigrade. Along with that, because the temperature they are on the higher side, so cooking of the product, it also occurs. Then at the end, depending on the type of the die, we may provide specific shape to the product, and the moment molten mass comes into outside, it comes in out from the die, we may have expansion or puffing of the product. We may carry out agglomeration. Specifically, this might be possible in case of if we are using the cold extruded product sort of thing. Then some amount of moisture, it is also being released from the product, and it number of times, due to the this passing it through the extruder, we may also get the dehydration, unitization of the product can be achieved. Further, people, they have also reported that the pasteurization or sterilization of some of the products, it is also achievable in case of in extruders. Then during the process of this extrusion cooking, specifically the moment we are feeding, so this from this typical temperature pressure with regard to this barrel length diagram, you can see that as the product it moves from the feeding, next is the compression zone where the kneading of the product or kneading of the ingredient it is being carried out, and finally in the metering zone this cooking is being carried out. And within the cooking section or this within the metering zone, the temperature and pressure of the this total material or the molten mass, they are on the higher side, and the moment it comes out from this metering section or this it comes out of the die, its temperature instantly it goes down, and along with that expansion of the product it may occur, specifically if we are having high starch product or in the raw material. If the product it doesn't have this high starch or this we may not find that more amount of expansion. More expansion it is being observed if we are having more amount of starch. These are the some of the other configuration of the screws which I have already mentioned. Then these are the various factors which may influence the product characteristics as well as the end product, as well as number of times you can vary these factors to develop a product as per your requirement. So they are being categorized into primary extrusion factor, like extruder model is one. The moment you have purchased the particular model, then you cannot go beyond what the model specifications are there. Say for example, if the rotation speed or this RPM of the screw it is up to a certain limit, then you cannot go beyond that limit if you have purchased a particular model. Or if you are having this extruder in which you have external heating system, then you can carry out external heating, or if you can heat your product during the processing, but if you don't have that external heating system, then you cannot carry out the heating within the extruder. Similarly, other parameters which may influence the end product, they are the feed composition. That means what are the raw material or the ingredient present in the feed, then what is their particle size, then what sort of preconditioning is being given. Normally for the extruded product, a little bit of preconditioning is being carried out. Normally this preconditioning, in the process of preconditioning, we are adding we are mixing the ingredient in a homogeneous way, or this, so that the whatever the ingredients are there, they get distributed throughout the mass, as well as number of times we may add some amount of moisture or the water or maybe fat or oil into the product. So these are the some of the things which can be done. Then the feed rate, that is at what rate you will be feeding the product into the container or this into the extruder. Then number of times you may have system for addition of water, and number of times you may not have system for addition of water. So you have to control this. If you have to add water into this extrusion process, then you have to control this water rate. Otherwise you cannot, if it may affect the different qualities of the end product, specifically expansion of the product. It is influenced by this addition of water. Then barrel temperature, it influences the cooking aspect of the product. Then screw configuration, already I mentioned this simple example of the single screw and then twin screw, but within the screw there might be lot of there might be variation. If you will be this looking for the screw characteristics, then the there are different parameters with regard to the this screw angle and then flight, so pitch. So these are the some of the parameters within the screw, which if you have a particular type of screw, then you can control the product characteristics in a better way. But during the moment you have started your process of extrusion, then in between you cannot remove or you can change the screw configuration or something like that. Then you can control the speed. It is important to obtain optimal product. If you are not able to control this speed, number of times choking within the extruder it may occur. Then die, number of dies or its geometry, what type of die we are using, or whether it is a single die, single hole die, or it's part of the dies which are being fitted so that you can get a whole geometry. So that is another factor. Then we may have secondary extrusion factors, which may include this product temperature, then the viscosity, pressure, or specific mechanical energy. So these are the other parameters which as such you are not able to control, but it depends on the primary parameter, specifically what different sort of ingredient you are using, what screw speed you are utilizing, or what type of die you are using. So all these parameters, they may influence your viscosity, pressure, as well as your specific mechanical energy consumption. So these are being considered as the secondary extrusion parameter or factors. Then these are the normal steps. You may have different sort of ingredient. It might be rice, it might be wheat, it might be corn, or it might be some other cereal or pulse ingredient, which can be first you have to convert that raw material into powder form, and if desired you have to carry out the preconditioning. You have to uniformly mix it, and then that mixed material, it is ready for extrusion, or this after conditioning that product can be further passed into the extruder. Then this material, it can be passed and you may get this extruded product. This is the corn ball sort of product which is being obtained in this presentation or this slide. Then there is typical classification of the ingredient which are being used for production of extruded product, and this particular classification, it is being done by Robert Guy, and he has classified different ingredient being used for extrusion process into 7 category. Group 1, they are being called as structure forming material. Structure forming material, it might be either starch or it might be protein. So the moment you are having more amount of starch in your product, then you may get the expansion characteristics, or the product, it may get more expansion. And the moment the protein content, it is on the higher side, then the expansion will be less, but you may get the this textural characteristics, or the texturized the product might be more in textural this texturized vegetable protein sort of product might be achieved. So within that, other than that, second category is dispersed or face filling material. It might be again in case of if you are using the maximum amount is starch, then the second portion will be the other portion, or the filling material might be protein or maybe fiber. But in case if you are using the protein as this structure forming material, then in that case this starch or fiber, it might be this filling material. Then third category of ingredient, they are being classified as the plasticizer. In that category, you may add some sort of oil, this which gives the plasticizing effect. to the product. It may be either water can be used as a plasticizer, or number of times people they also add some oil and fat in the range of 1 to 2% as a plasticizing agent. Further to this impart taste to your product, some of the ingredient like sugar and salt, they are added. Number of times they are being added in the plasticizing agent being used in the powder form, or which is being made or this prepared in the solution form, or it might be added in the powder form in the ingredient itself. So it can be added like that. Then you may have some sort of nucleating substances like calcium carbonate or magnesium carbonate. They too are being used. And other category of ingredient, they are the coloring substances. Another is the flavoring substances. So these are the major classification of the ingredient which are being used in extruder. Then these are the different shape products which can be obtained. You may obtain depending on the type of the die being used, you may achieve these different sort of product. And normally some of the cereals which are being commonly being used to achieve these different product, they are being listed over here, like this to achieve the ball sort of shape. This normally corn, it is being used, it provides more this expansion. And we may also achieve this rice shape. Already Mishra sir has worked a lot with regard to that product being formed from this broken rice. So that can be achieved. Or we may have these different sort of product depending on the type of the die which is being used in the extruder. We may have these different sort of product. So whenever we are using this different products or this they may have different sort of this texture, like the ball shape, they are more in crispy in nature and they are highly expanded. However, rice shape product, they are crispy, but the expansion, it is comparatively less, and the hardness, it is also less in this case. Loop sort of product, they are crispy, however they are more harder in nature. So depending on the type of the ingredient, we may have the different texture being achieved in the extruded product. So these are the some of the products which you can prepare or one can prepare. So we may have different sort of ready to eat breakfast cereal like puffed cereals or flake cereals, then high fiber spreads or puffed snacks, half products or pellets, crisp breads, this different sort of this confection. Licorice or chocolate sort of product. So whenever we are talking with regard to the confectionery items or this sort of product, so normally it's the cold extrusion process or this to provide the shape to the product. Then we may have texturized protein. We may also produce this infant foods, maybe weaning cereals, etc. Then this is the classification of the extruded snacks. They are being categorized into 3 generations. First generation, they typically were being prepared from natural products, and the major purpose of those products was specifically snacking. They consist of nuts or potato chips or popcorn, etc. Second generation, those snacks of single ingredient, simple in shape product like corn tortilla, chips, etc. And the third generation snacks, they are also called half product or pellets. They too are being produced through this extrusion cooking process. These are some of the typical diagram showing the flow diagram showing this how it is being prepared. Then these are the different sort of product which can be prepared and what different sort of cooking it is being achieved. In this case, we may have flake cereals with the help of this extrusion cooking, and in this case we need to have hydrothermal mostly in case of extrusion cooking, we may have puff serial. A number of times, if we may also obtain the serial mixes. We may cook the product, and the cooked product, it may be further ground and then dried to achieve the different sort of cereal mixes, or maybe we may have different sort of nuts into it, so that we may achieve that sort of product. Then different sort of ready to eat snacks, they can be this is the on the right, you can see that is the normal or the traditional process of that, having that snacks. On the left, you may see that the after extrusion, only drying will provide us the snacks. However, in case of this traditional process, it's a cold extrusion, and then those dough balls, they are again formed and dried or tempered, and then the tempered product, they are further puffed with the help of gun or other sort of puffing systems. So that is the sort of expansion. This puff product can be obtained through this extrusion processing. Then another is this flake product. They too can be achieved through this extrusion process. So in the case of conventional process, you have to cook the ingredient, then temper it. You have to crumble, then dry, further temper. Then after that, you have to carry out flaking. However, in case of extrusion, you have to add the raw ingredient. You have to add the water, and then you will be getting the balls or pellets, and then you pass it through the flaking machine, and then after that you can carry out toasting, then cooling and packing of the product. So number of steps of tempering or drying, they are being reduced in case the moment we are using extrusion in the process. So these are this ingredient. Then various anti-nutrient or allergen compounds, they too are being reduced through the process of extrusion cooking. So you can see that the allergens, they too can be reduced. Glucosinolates, glycoalkaloids, gossypols, all these different sort of anti-nutrients and allergens, they too are being inhibited or reduced by application of extrusion. Then some of the effect of extrusion on different sort of nutrients, you may see from this table that with the increase in increase in the temperature, gelatinization of the product, it is being gelatinization of the starch, it occurs, as well as dextrinization or conversion of starch into dextrin, it also occurs simultaneously. However, this lysine content within the product, it is being lost, which is one of the heat sensitive constituent. Similarly, this vitamin B1, it is being reduced, vitamin C, it is being reduced. So some of the component with extrusion, they are being lost. So number of times, that's why this people, they are saying these snacks which are being obtained through extrusion as the they categorize them, these extruded product, into junk category. So other parameters, they like screw geometry, RPM, they have effect on different these gelatinization, as well as the this vitamin preservation on the during the process of extrusion. And specifically lipid soluble vitamins, they are being retained more as compared to that of the case of frying or other processing, if we are doing it comparing it with the extrusion. So more amount of those lipid soluble vitamins, they are being retained, even though the temperatures are in the range of 100 degree or so. So these are the some of the typical cost of the different type of extruders for processing of the product. So different production rate wise it has been given, and I've taken this from the book of Riaz. Then the application part, we may produce different sort of product like texturized vegetable protein. They can be obtained with the help of this extrusion. So these are the steps being involved. So you may dehull, then remove the oil from the soybean and then convert it into flour. Then some amount of this vegetable oil, it is being added and it is being extruded with the help of the extruder, and you are getting this texturized vegetable protein sort of product, which these sort of product, they as their expansion, it is being achieved, expansion as well as the typical texture, it is being achieved once they are being cooked, or they are having better water absorbing capacity as compared to that of the normal other puffed snacks. Puff snacks, they get expanded. Then another this extruded product, that is the pasta or similar sort of product, which are the normally the cold extruded product. You can have different sort of extruded product. Then we can have these different sort of extruded product like puffed rice or maybe flaked rice or broken rice can be further used to prepare whole rice. So that is one of the application, and a lot of work has been carried out by FCTL lab by specifically under the guidance of Mishra sir, for converting the broken rice into the consumable rice form, or making it similar to that of edible rice. These are some of the pictorial presentation I have taken from some sources. Even some work has been also carried out by this Anubhav Mishra on preparing this dal sort of product under the guidance of Dr. Mishra. Then even different type of floating, slow sinking or fast sinking products for specifically for fish, they too can be prepared with the help of this technique. So with this some of the overview, I will be a little bit telling you about the work which we have carried out at our university. So we have more initially, or this initiated our studies on this BPTL extruder. So most of the studies which we did initially were on this, and later on we purchased this other level, this commercial or this pilot scale extruder. So we prepared the extruded product from the okara powder, which is okara. Normally it's a waste being obtained after extracting this milk, soya milk. So that it's quite large amount of waste this being generated whenever we are processing the soybean for preparation of soya milk. So we try to utilize that okara powder along with the corn flour with the help of this BPTL extruder, and we were able to achieve that around 10% of this okara can be utilized to prepare that extruded product. So around this 10% of corn flour, dried okara flour, along with 90% of corn flour. At these processing condition, provided us a product which was acceptable, and it was having a shelf life of around 4 months at ambient conditions. Another these are some of this typical RSM graph for different characteristics, specifically expansion ratio and then bulk density. This work was being carried out by one of our MTech student under guidance of Dr. RF Sutar. Then We currently are working on utilizing this fruits and vegetable byproduct in the extruded product, and these are the some of the things or some brief information with regard to why we should have this fruits and vegetable byproduct in our product. So this is one of the trend this innovative trend which is going on, and already a lot of people they have worked as well as they are still working on producing this extruded snacks from different sort of byproducts. So because this different sort of byproducts which are being obtained from fruits and vegetables, they are rich in fibrous component, as well as other than that they are having different bioactive component, as well as they may have different type of antioxidants. So this improves the some of the um, nutritional aspect of the food, which normally this of the extruded product, which initially as mentioned it consists of the starch base or sort of food, and which was being considered or is being considered as a in the category of the junk food or something like that. So different type of this raw material they can be used for preparation of the product, and these are the some of the products which can be used. We have tried to utilize the tomato pomace, and tomato pomace, it is rich in this lycopene, and lycopene itself, it is having some amount of this benefits with regard to the different sort of health problems, specifically cardiovascular diseases or cancer. So it can prevent the different sort of oxidative damage. So we try to incorporate this tomato pomace into the this. We first converted that tomato into powder form, that juice which was being used for production of puree, and the pomace it was dried at around 60 degrees centigrade, and the powder which is being shown over here, it was being used along with some other ingredient in this product. We try to incorporate this make it nutritious in terms of we added this pulse as well as corn flour along with this tomato pomace, and we achieve a product which was rich in lycopene, and this we were able to replace around add around 5% of tomato pomace into the product, and that product it can be stored safely for a period of around 6 months. So these were the optimized condition for this incorporation of pomace in this extrusion process. The barrel temperature was 120 degrees centigrade, and the screw speed was around 425 rpm, and it was having 15% moisture content. Then another product along with tomato, with this we further added this carrot. So this tomato carrot blend, it was being maintained in a ratio this 1:1 ratio, and then that powder blend was incorporated to produce another set of snacks. So in this case our objective was to this lycopene was being provided from this tomato, and this carrot, it provided this another vitamin, that is carotene. And so we tried to develop a product which was rich in carotene as well as lycopene. And we also carried out some trial for product formulation with in our this commercial or pilot scale extruder. So it's we procured it from China, and the recipe, it was being given by Amul, and we tried to develop the product. This particular is the extruder. Here it's hopper, and these are the some of the processing parameters which are being set within this through this extruder control panel. And here we are getting the end product, and these end product this corn balls, specifically they are being called as a gathia here. they are quite popular in children, and this sort of product we prepared it for Amul. This product, it is being fed to the dryer, and here this end product, it is being obtained in form of a ball. So this trial we carried out for the product development studies for Amul. Then specifically with regard to this trends in food extrusion, specifically one of the trend is that utilization of byproducts from fruits and vegetable industry, so that the fiber component or other nutrient which are there in that this byproduct, they can be incorporated into the this end product. That is one thing. Then other than that, this functional food product development, that is another approach. Like we may incorporate this different sort of ingredient into the this extruded product to enrich it with the nutrient which are the children they might be deficient, or this we may, depending on the target group or the target population, we may develop those sort of product. Specifically one of the product Mishra sir has developed, that it is rich in iron rich or iron fortified rice, or similar sort of product can be thought of, or it can be developed. That is another trend. Then this is the 3D printing of food products. Different type of food products, they are being printed with the help of, that is also a process of extrusion, where this again the product, it is being extruded, and we are designing the food or printing the food as per our requirement. So some work has been we haven't carried out any work, but especially in India, IFPT, they are working on this development of 3D printed food, or development of 3D printer, something like that. Then this supercritical fluid based extrusion, this is again being used, though lot of work, it was initially initiated somewhere in Dr. Rizvi's lab by Dr. Sajid Elavi, and they tried to incorporate the supercritical fluid into the extruded product, so that the along this supercritical fluid, it as during the process of extrusion we are having very high pressure. So with the application of the supercritical fluid, again we are this fluid itself, it is also having very high pressure, so it can be incorporated into this product, and we may be able to produce that product with better nutrient quality, which are normally being some of the nutrients which are being lost, especially when we are carrying out the normal thermal extrusion process. So here the nutrient, they can be retained, more retention is possible. So this is with regard to some of the common consideration whenever one is talking with regard to the 3D printing, specifically this rheological properties of the product which we are planning to extrude, or this which in terms of this 3D printer are being called as inks, and their associated processing conditions, like means will be the up to which layer that this ink it will be imparted on the product or something like that. Then the temperature of extrusion, that is another important aspect, because the temperature, it may number of times if we have some amount of starch or similar sort of component within the this as a ingredient within our ink, then it may get gelatinized, or some of the protein it may get denatured, and they may not be they may choke nozzle or something, some problem might be there when we are talking with regard to that sort of product. Then this again, for how much duration that printing it is to be done, and after that what different sort of post-processing operations they are to be carried out. These are some of the common consideration when we are talking with regard to the this 3D printing. So this is with regard to the 3D printing of the products. Then specifically some of the challenges in the food extrusion, they are especially maintaining the nutrient or phytochemical in the end product. It can be some of these can be maintained if we are, as I mentioned, utilizing the supercritical fluid into incorporation. But as such, commercially, that technology, it is not being used. I do not have exact idea, but however, the patent has been done for this technology. But that is one thing. Then depending on the type of the product, we need to design different type of die. That might be another challenge. Types of the die, as per, like we need to have a specific die for production of rice. Similarly, specific die, it need to be there for production of this dal and log. So we need to have this idea with regard to the product behavior, how it behaves whenever it is coming through it is coming out of the die, and what type of shape it will take. So that on the basis of that is one of the challenge. Then during the processing within the extruder, how this rheological characteristics of the product changes, it is another issue. We do not have much idea or much data with regard to that. It need to be generated specifically for the development or design of this 3D printing or similar sort of devices. Further, this modeling with regard to this extrusion process, that it also need to be done, so that some of these datas, if some of these data are available, then we can develop some of the design aspect. Maybe a screw design or maybe a die design may be carried out on the basis of the available data that need to be developed, or some sort of database need to be generated. Then post processing consideration in 3D printed food, like though we have developed, but after processing, maybe whatever the means we are using, it should retain that particular shape. So if it is changing the shape, then our objective of developing that 3D printed food, it is being defeated. So these are the some of the things which I wish to discuss, and with this I come to the end of this. These are the some of the references, and you can see some of the recently some of the works they are being published. Like you may find that this comprehensive review in food science and nutrition, food science, food and food safety. They are publishing review on extrusion technology. Similarly, in recently, this other is they are also working on this extrusion cooking of protein based product. So though this technology is old, but people, they are again looking back to this technology, and they are reinventing, and they are looking for some of the developments specifically in this case. So this is all about. So now I am available for the queries being asked by the participants. So I will be logging off of this presentation.
Sir, good evening. I'm Anand, and I had this one query. When we talk about 3D printing, at times we have layers in that. So, like if we are 3D printing a food product, then one layer has to get attached to the subsequent layers. So, how do we ensure that? Like one thing you have mentioned about plasticizers. So, can you please elaborate on that aspect, as in how the layers can get stuck to one another so that we get a full food product?
So for that you have to test already you mentioned with regard to the plasticizer, but you have to check for number of times the ingredient which you are using. Within the ingredient itself there might be some of the constituent which may act as a this bonding, which may be helpful for bonding of the product in the other layer with the next layer. But you have to carry out that trial. I do not have exact idea that what ingredient they are suitable, because I haven't worked on. I just, that's why I elaborated that the most of the work it is being done at IIFPT, and you may get some more information with regard to that. But probably there might be ingredient which may adhere to the other layer. So you have to check the how the bonding with between those two different sort of ingredient it occurs. So if you have some idea with regard to the chemistry aspect of those ingredient, then you can be able to develop that product in different layer form.
Okay, all right, sir.
Sir, may I ask a question?
Yes, yes.
Sir, good evening, sir. Sir, you were talking about supercritical fluid extrusion. So I want to ask that what kind of benefit will it give by infusing supercritical fluid in extruded product? Because in supercritical fluid extraction, what we generally did, there we either extracted the desirable product or undesirable product. But in the case of extruded, it is a closed barrel, and after that the product is coming out from a constricted die. Then what kind of benefit are we getting? Means, is there any reduction in temperature or something like that? Because
yes, yes. This supercritical fluid, it is being under the for that also you need to have high pressure. It is being this being inserted into the system under high pressure, as well as due to this particular fluid, the temperature of the product itself it also gets reduced. That's why some of the nutrient within the product they are being retained. So that is the reason it is being advocated. However, there is no commercial this work or this. I haven't come across through some sort of commercial production of the supercritical incorporated extruded product. I have come through this information only through some of the papers, and specifically some work has been carried out from one of this Kharagpur's alumni, Sajid Alawi and his team, and Dr. SSH Rijvi. So the patent it is in the name of Dr. Rijvi and some Mulwane.
So the query was because of the fact that it is using either it will use carbon dioxide or some other supercritical fluid. So won't there be any risk of residue inside the extruded product, or the carbon dioxide will evolve?
If carbon dioxide is there, then certainly you might be knowing that at the moment you are incorporating it into the extruder, so it will get converted into gaseous form. It will not remain into the this supercritical form, because the temperature inside the barrel itself it will be higher, and the supercritical fluid it will get converted into the CO2 form. So it will get released. It will not get entrapped into the product. Other than that, even in the number of products, we have this CO2 as this for leavening it is being used, or some of the it itself have some, it doesn't have a major this health issues.
Thank you, sir.
In fact, Indra, the question which you are asking and the Pandey ji has rightly told, that is in fact in the polymer industry, all right, this practice is there in the food processing. It is coming, but in the polymer industry during extrusion, supercritical fluid extraction, the carbon dioxide, SCFP carbon dioxide, they infuse inside the barrel, and the main purpose is that it reduces the temperature of the product during extrusion and helps in better retaining the components and characteristics, etc. of the product. That is the.
Maybe, sir, it can also enhance the puffing of the product.
Yes, that may also some leavening, etc. maybe in the food material that may have, but at present they are using in the polymer industry. It is for that nutrient retention and then expansion, etc.
Okay, sir. Thank you.
Now even extrusion is used, also advocated to be used as a reaction chamber, extruder barrel inside the, even for the various reaction to encourage the reaction, whether you can easily maintain the temperature, pressure, even the carbon dioxide concentration and other things. So the reaction can be facilitated in all these.
Okay, sir.
Right. There are no.
Yes, yes, yes. It's very interesting. Whenever you are doing it as a large scale, certainly a number of times this with the, if you are scaling it up, the conditions whatever you have optimized at laboratory scale, they number of times they didn't work. So you have to carry out trials in the scale up format. So as such, you have, on the basis of the trials, you have to perform certain trials, and then only you will be able to know whether this whatever the conditions you have optimized, they are working or not. As such, there is no specific ratio on the basis of which one can tell. So if there are certain models, we have to develop some sort of mathematical models to simulate the exact conditions which are happening, then only one can predict it in the scaling. But we don't have that sort of data to model the behavior of the product within that. So maybe CFD can be utilized to model it on the basis of that. You may find out some sort of ratio so that you can predict that this is the ratio.
So I think if there are no more queries, so you can conclude. There are. Yes, please go ahead.
Yes. Thank you for that, sir. I would like to express our sincere thanks to Professor Hridyesh Pandey, sir, for giving an excellent coverage on the topic of food extrusion. The interesting part of the talk was that it started with the theoretical basics, and then it detailed us about the current research that is being carried out in this field. Also, particularly attractive to me was that Professor Pandey also presented glimpses of the extruders which are being used in his lab. So, which was like a virtual tour of the lab to us. And so, on the behalf of all the participants and FCTL, I would like to extend a heartfelt gratitude to him for delivering an enlightening webinar. Finally, I thank all the participants and Professor Mishra for organizing the webinar series.
I also personally thank Dr. Mishra sir as well as other FCTL members for inviting me to this gathering as well as to this webinar. I thank you all. Thank you, sir.
Thank you, sir.
Thank you, sir.
Oh, okay, ji. Bye bye. Thank you.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.